All right, let's jump right in. Welcome to this high-yield explainer. Today, we're setting up a massive macro to micro journey. We're going to start from the absolute vastness of the universe and zoom all the way down to the specific physical geography of India. If you're studying for competitive exams or honestly just want to build a rock-solid academic foundation, you are in the exact right place. Let's lock in these concepts visually and efficiently together.
Here's our roadmap for today's study session. We'll be hitting the solar system, the geographic grid, Earth's motions, maps and domains, major landforms, and finally, the geography of India.
Starting off with Section 1, the solar system. Zooming in from the universe.
Okay, before we even look at our own planet, we've got to understand its neighborhood. And here's a fun, kind of counterintuitive fact for you. Our very own sun is actually a star. Yep, it's simply the closest star to us. Now, to easily organize our solar system for the exam, you've got to lock this classic mnemonic into your memory. My very efficient mother just served us nuts. This perfectly orders the 8 planets by distance from the sun. It also splits them up nicely for you. The first 4, Mercury, Venus, Earth, and Mars, are your inner rocky planets. The last 4, Jupiter, Saturn, Uranus, and Neptune, well, those are the massive outer planets made mostly of gases and liquids. Let's move on to our absolute favorite rocky planet, Earth. Since childhood, we've all seen these perfect, round globes, right? Well, it turns out Earth actually isn't a perfect sphere. The specific academic term you need to know here is a geoid, which literally just means Earth-like shape. Think of a rubber ball. If you press it gently at the very top and the bottom, the middle bulges out, right? That is exactly what happens to Earth. It's slightly flattened at the poles and bulges right at the equator. Let's move on to Section 2, the geographic grid, pinpointing locations on Earth. So, now that we understand our planet's true shape in space, how do we actually find anything on it? I mean, a sphere has no corners, so we rely on a grid system of imaginary lines. The horizontal lines are called latitudes. The equator, of course, splits the Earth right in half at 0 degrees. But for your studies, you really must know these 4 crucial horizontal lines. The Tropic of Cancer and Tropic of Capricorn dictate the Earth's torrid zone. This is where the sun hits directly, creating immense heat. Above and below those, reaching up to the Arctic and Antarctic circles, we get the temperate zones. That's where the sun's rays are slanted, which gives us much more moderate climates.
Now, check this out. Here is a step-by-step mathematical breakdown that is absolutely crucial for exams. While those horizontal latitudes give us heat zones, vertical longitudes dictate global time. It works exactly like this. Earth spins 360 degrees in 24 hours. Do the math, and that's 15 degrees every single hour. Break that down even further, and it takes the Earth exactly 4 minutes to rotate just 1 degree of longitude. This means for every degree you move east, the time is 4 minutes ahead, and for every degree west, it's 4 minutes behind. Really simple math, but super important to remember.
All right, Section 3, Earth's motions, the mechanics of time and seasons.
To solidly lock this into your study notes, let's quickly contrast Earth's 2 dynamic motions. First, you have rotation. This is the Earth spinning on its own axis, kind of like a top. That takes 24 hours and gives us day and night. Then you have revolution. This is the Earth's long, elliptical orbit all the way around the sun. That takes 365 1/4 days, and it is the absolute driver of our changing seasons.
But hang on a second. What about that 1/4 of a day in the revolution? Why exactly do we have a leap year every 4 years? Well, it's just elegant math. Every single year, our orbit leaves us with an extra 6 hours. Over 4 years, 6 plus 6 plus 6 plus 6 equals exactly 24 hours. We pack those extra hours into a single extra day and just tack it onto February. So our calendar perfectly balances out the mechanics of the cosmos.
And this perfectly explains a classic exam favorite fact, our precise 23.5-degree axial tilt. See, the Earth doesn't sit perfectly straight up and down on its orbital table. It actually leans. Because of this permanent tilt, different hemispheres point toward the sun at totally different times. So when it's absolutely freezing in the northern hemisphere in December, Australians, down in the southern hemisphere, are celebrating Christmas in the middle of a bright, hot summer.
Moving right along to Section 4, maps and domains, flattening and dividing the Earth.
Okay, transitioning from planetary mechanics to human tools, we use maps to study the Earth's domains, namely the lithosphere, hydrosphere, and atmosphere. Now, compressing a 3D sphere into a 2D map inevitably causes distortion. I mean, just try peeling an orange and flattening the peel on a table without tearing it. But focusing specifically on the atmosphere, for anyone prepping for a test, this vertical order is highly tested material. From the ground straight up, we have the troposphere, stratosphere, mesosphere, ionosphere, and finally the exosphere fading right out into space. This gaseous shield is literally what protects us from harmful solar rays.
Now there is a totally fascinating paradox when it comes to our hydrosphere. Our planet is affectionately known as the blue planet because a massive 71% of it is covered in water. Yet, we're constantly hearing about water scarcity. Why is that? Because over 97.5% of that water is in our oceans. It is incredibly salty and entirely unusable for human drinking or agriculture. Only a tiny fraction is actually accessible freshwater.
Which brings us to Section 5, Major Landforms, the architecture of the surface.
The solid lithosphere might feel permanent under our feet, but is actually a dynamic battleground. It's constantly being sculpted by internal geological pressure pushing up and external erosion tearing it all down. This epic battle creates three distinct types of mountains that frequently pop up in competitive exams. First, we have fold mountains, created by the Earth's crust literally crumpling together, like the Himalayas and the ancient Aravalli Range. Then we've got block mountains, formed when massive chunks of Earth crack and vertically drop or rise, like the Rhine Valley. And finally, volcanic mountains, which are built up over millennia by cooling lava. Think Mount Kilimanjaro or Mount Fujiyama.
Now, comparing plateaus and plains really builds our understanding of human settlement. Plateaus are elevated flatlands. Picture a giant raised table. They are incredibly rich in mineral deposits like gold, iron, and coal. The Deccan Plateau is a perfect example of this. Plains, on the flip side, are flat lowlands formed over millions of years by rivers depositing highly fertile silt. This makes it super clear why human civilizations naturally gravitate towards plains. The fertile soil and easy terrain make them the absolute most densely populated areas on Earth.
And finally, Section 6, the geography of India, the micro zoom in.
Do you remember our longitude math from earlier? When we apply it to the vastness of India, something pretty incredible happens. Between Gujarat way out in the west and Arunachal Pradesh in the east, there's a longitudinal gap of about 29 degrees. Multiply that by 4 minutes per degree, and you get a massive time difference of almost 2 whole hours. So, to avoid complete administrative chaos, India adopted a single standard meridian running right through the middle of the country at 82 degrees 30 minutes east. The time on this exact imaginary line dictates the clocks for the entire nation.
Physically speaking, India is a showcase of basically every major landform we've discussed today. For a quick, high-yield summary, up in the north, the Himalayas act as a massive natural wall with 3 parallel ranges. Just below them, formed by the mighty rivers flowing down from those mountains, are the incredibly fertile northern plains, which support hundreds of millions of people. And to the south, we have the triangular, mineral-rich peninsular plateau. It is a geographically diverse masterpiece.
Our journey today, from the edge of the solar system down to the soil of India, reveals an incredibly delicate balance. Everything is connected, from the tilt of our planet in space to the monsoon rains feeding the plains. So I want to leave you with a question to chew on. If just a slight shift in our axial tilt or a minor change in global temperatures can completely alter our rivers, our plains, and our seasons, how long can Earth's delicate biosphere sustain our current rate of human interference? You see, geography isn't just a list of facts for an exam, it's the study of the fragile, interconnected system keeping us all alive. Thank you so much for joining me on this explainer. Keep studying hard, stay curious, and I'll see you in the next one.